Today we are going to cover our lecture for the week 12 for the course of Fundamentals of Programming. Let's see what we have in our today's lecture. In today's lecture we are going to cover functions, and with functions we are going to cover different things related to function. For example, passing arguments to a function, returning values from a function, how we can pass by value, how we can pass by reference, and finally we will also cover the overloaded functions with some definitions of inline functions. But initially, first we need to understand what are the functions and how and why we need them. A complex problem is often easier to solve by dividing it into several small parts, each of which can be solved by itself. This is called structured programming. These parts are sometimes made into functions in C++. Main then uses these functions to solve the original problem. If we have a very big problem to solve, or we have to create a software for a big problem or a big domain or a big scenario, then in that case it is easy for us to divide our problem into different parts. For each part we can define a separate function, and we can then execute those functions from our main function. In every C++ program there is a mandatory function, that is main function. Without main function no C++ program can work. So with the C++ program we need a main function, as we always had. So from main function we can call different other functions as well, and each function can represent a specific type of a work, specific part of a work, which can help to solve a bigger problem which we want to create. A function groups a number of program statements into a unit and give it a name. This unit can be invoked from other parts of the program. So function is nothing else but grouping some instructions into one place, into a unit, and giving it a name. For example, in our program we have different functionalities like addition, subtraction, multiplication, division. So if we want to separate these functionalities, so we can put all the different functionalities into different functions, like addition into addition function, subtraction into subtraction function, and so on. And then we can call these functions, or we can invoke these functions from different parts of the program whenever and wherever it is required. Using function, we can function with the functions. We have to have to have some idea with respect to what are the main advantage of these functions, and there are some other you can say abbreviations we are going to use with respect to functions. First is that for function, the benefit of the function is that we can modularize our programs. It means we can divide our program into different modules. If our program is going to have different modules, for example your Zepdesk portal, in Zepdesk portal you have a student portal, you have a faculty portal, you have a PM portal, you have an HOD portal, and so on, with respect to different roles in the university. So every role can be shifted to a particular function so that it can be separated from the other program, and also it also provides some reusability. For example, faculty also want to know the CGPA of a student also want to know the CGPA of a student, PM also wants to know the CGPA of a student, and other roles as well. So rather making a logic and rewriting it again and again for every user, for every type of a role, we can shift the CGPA calculation into a function, and then whenever it is required and wherever it is required we can call it. So it can also provide reusability effect. So, and we also can call it multiple times, as many times as we want to. Whenever we talk about the functions, we also talk about local variables. Whenever you create a function, any variable which is going to declare within the function, then it can be only accessed within that function only. For example, there is a variable simple integer x, and it is defined in a particular function. Let's suppose the function name is show, then it means this x variable is particularly can be used in only this function and cannot be accessed into any other function. In different functions there can be of the variables of the same name. For example, we have two functions, addition and subtraction, and in both functions we can declare the variables with the name of x, but both are actually separate because those are the local variables with respect to the functions. So within the function, that function is related to or belong to only that function. This is also called the scope of a variable. Wherever we declare the function variable, that variable scope is only bound to that function. For example, we declared a variable x in main, then it can be only used in the main. If we declared a x variable into another function called show, then it can be only used or it can be only accessed in the show function. But obviously, if all the functions are going to have different variables and they are not communicating with each other, then it can also create a problem. Let's suppose I'm the main function and I want to ask Ali to work for me as the addition purpose. For example, I'm doing some calculation and I asked the help from the Ali, and Ali is doing this calculation stuff, for example the addition stuff. So obviously whenever he needs to do the addition, I have to provide him some data. I need to give him some information, some values on which he can do the calculation, and then he can return me the answer. So for giving some information or sharing information between the functions, we need some parameters, and these parameters help out the functions to communicate with each other and exchange their data. And also the opposite wise, it is also going to work that function is going to receive some data from other functions, as well as it is also going to return the resultant value if required. What are the main advantages of the functions? In the functions separate the concept what is done from the implementation how it is done. Means I'm going to do work, I can say, for example, I'm a main function. On a particular line, I can say I have done the addition here. But how the addition is actually implemented, it is somewhere else place. So what I is done is addition. How it is done, it is written somewhere else in the function definition. And if we need to know about it and if we are interested in the details, then we can go to that function's body and function definition to know how it is working. Secondly, function make programs easier to understand. If you put everything in a single main function, then your program is going to be is going to be a big mess that it is very difficult to understand. For example, consider this Zapdesk portal. If you think Zapdesk portal is going to put everything of Zapdesk portal in main function, then no one is going to understand it. But if we divide it into different functions, then it is easy for us to understand, okay, login is working here, the CGP is calculating here, and so on, different functionalities, whatever we required. Last but not the least, functions can be called several times in the same program, allowing the code to be reused. So the main advantage is if we want to do a same task again and again in our program, then we don't need to write its code again and again. We can simply write its code once in a function, and then we can call this function as many times as we want to. So we don't need to write same code again and again, and we can reuse the same code in different execution steps of our program. Simply, we can understand the flow of a function or the working of the function through this diagram. इस diagram में जैसे आप देख रहे हैं, you have a single function that is void function 1. Let's suppose it's a single function like a main function. It is a function, you defined it somewhere in your code, and you have the main flow of your program. Different instructions. And in this instruction, at the 3 places, you want to work exactly what this function is doing. So you don't need to write up that code. You just have to call the same function 3 times wherever you want to execute it. Because compiler is only going to execute the main function. Compiler do not run any other function unless it is called from the main. So some compiler is simply going to start from the first line of the main function to the last line, and if we need to work something differently which is written into another function, so we can simply call this function, and we can also access this function's data by parameters or by the return values as many times as we want to. Let's suppose a simple example to understand the functionality or how function works. first consider a very simple example. Let's suppose you want to print this table. For printing this table, you can see there is a same thing we are doing again and again. One is these static lines. Other data is different with respect to different data type. We want to present the ranges, or we can have any different data, but the common thing or the same thing we are repeating in this program is these static lines. So we have a static line, we have a static line, we have a static line. One of the thing is that we write the code for these static lines again and again in our program using loop or using simple as cout statement. But if we want to, we are not comfortable that again and again we are writing the code for printing a static line, we can simply do this, that the working of these or any statement which are going to give us the static line, we can put it into a function and then we call it in our main function as long as we want to. For this purpose, first of all, we need to create this function. For creating the function, we need some different components. Whenever you are going to create a function, you have to understand different components of a function. Within the function, there are different other components, but these components are with respect to whole structure of the program. With respect to whole structure of the program, you are going to cover three types of the components. First, function declaration. Second, the calling of the function, and the third, the definition of the function. Without having any of them, you cannot exactly implement or run the functionalities, or you can access the functions. For accessing the function, so you need proper function, these things: declaration, function, definition. In some cases, declaration can be missed, and in the coming slides I will cover how we can miss these declarations. But for now, you have to stick on the point that we must need a declaration, we must need a function calling, we must need a function definition, then our function are going to work. So let's start with the first function declaration. So let's start with the function declaration. How we can first of all declare the function. Like the variables, whenever you are going to use any variable, the first task is to declare a variable. Similarly, whenever you are going to use any function, you need to first declare it. Declaration is just a kind of a flag for the compiler to know that this function exists, and after the declaration you can anytime call it. If you do not declare a function and you defined it somewhere later in the program, then if you call it first, your program or the compiler create problem for your execution that this function do not exist. So it is a kind of a flag very initial from before the main function that this function exists in this program. So anywhere from anywhere in the main, from anywhere in the any other function, we can call it. So first of all, the task is to declare a function that this function exists in our program. How we can define or declare, how we can declare a function is something. For example, the task is the same one. We want to create a function for the star line. Always try to use the proper naming for your function, that your function name also depict what it is working and how it is going to work. So our function name can be a star line. You can also call it a fancy line, you can also call it a simple line, or you can call it a header line. Any name is suitable with the same naming convention as for the variables. So there can be any function name. The two things, or you can say you must always have three things whenever you are going to declare a function. First of all is the data type. Like the variable, in the function as well, we have to define the data type of the function it is returning. Any value this function is going to give back to the caller, then the data type of that data is going to be written here. For example, the star line is not going to give anything. Star line is simply what is doing, it is printing something on the screen, but it is not providing any data back to the function, for example the main function. To main function is calling this function, but this function is not returning anything to the main, because it is simply printing something on the screen but also not providing any information to the main function. So first of all, we need to write void. It means this function is not returning anything. but we cannot skip this. If it is not returning anything, we cannot skip it. We must have to define the return type. So return type can be void, integer, or any data type which default data types we have, or even the user defined data types. In the future we will also discuss about that, but for the time being, any default data type can be the data type or the return type of a function. Second thing is the function name. Function name is the same properties as the variable name. Whatever the rules are of the variable name can be the rules, are also the rules of the function name. Afterwards, what we need are the two small brackets, opening and close, and these small braces, under these or between these braces we have to define parameters. This function can have or can take information from the caller. If someone is calling this function, that caller can also provide the parameters or any information to this function. For the time being, the main is not providing any information to this function, because this function is very simple. This function is simply going to print some starx which is predefined, for example the 45 starx or something like that. So we don't need, or main don't need to send any information to this function. If we are going to need some function, then we will define our parameters here, which we will discuss later. For the time being, this function, there is no parameter, so we can leave this empty. We don't have to write anything. After the declaration, what we need is the semicolon. This line is going to be before the main function. It is not within the main function. You have to define it before the main function, this declaration, so that in the main function you can call this particular function. So this is your declaration. For declaration, what you need: a declaration line, a declarator. A declarator includes the return type, the function name, small brackets, and within small brackets any parameters if required. The keyword void specifies that the function has no return value. The empty parentheses indicate that it takes no arguments. Now come to calling of this function. We declared this function, now we need to call this function. Wherever we want to print this static line, we have to simply call this function, and this function automatically will print the static line for us. From wherever you want to call this function, the calling method will be, you just have to write the function name and the brackets and then semicolon. You don't have to mention the return type, because this function is not going to return anything, so there is nothing coming back on it, so there is no requirement of the return type. You just have to mention the name of the function, the parenthesis, and if you need to send some data from main function to this function, if you want to send any data from to this function, then you can mention that data here, or directly the constants here or the variables here in which you have the data. So for the time being, we are not sending any data, so we are not mentioning anything in between the brackets. We just are going to mention the our function name and then the brackets and afterwards the semicolon. The syntax of the call is very similar to that of the declaration, except that the return type is not used. It should be the same function name should be same, the parameters we are sending. It is not possible that in declaration you say there is no parameters or there is no data this function requires, and when you are calling it, it is not possible that you send, for example, 123. So this is going to give you an error that for declaration you mentioned there is no data, you are sending this to this function, and now you are sending data to this function, so it can create problem. It should be similar to your declarator. The call is terminated obviously by a semicolon. Now the point of calling: executing the call statement causes the function to execute, that is, the control is transferred to the function, the statement in the function definitions are executed, and then the control returns to the statement following the function call. So how it is going to work, that it is simply wherever you are calling a function, your control will be shifted to the function. Within the function, whatever the instructions are, it is going to execute all of those instructions, and after completing that function, now it is the control will come back to the place from where it was called, so and continue the other statement afterwards. So this is your calling procedure of the function. Now come to the very major or the main part, that is function definition. Because we say that we have a function by declaration, that in this program we are going to have a star line function. So it was declaration only a indication for the compiler that we are going to have this function. Then from the main we also called this function, we call it wherever we wanted to print the star line. And now actually where the star lines are printing, that is going to be in the function definition. Function definition is the actual function existence. Wherever your actual function exists is your function definition. The definition contains the actual code of the function. The definition of the star line would be something like that your first line should be same as your declarator, as your declaration line, except the difference is the semicolon will be missing. You can, for your easiness, you can also copy your same line, so there is no ambiguity in it. Your line must be the same, so it should be the same as the declarator. Afterwards, what you are going to use these brackets as you use for the main. How we can write the main function? Void main brackets, then your curly brackets, and within the curly brackets you write all the code. Similarly for this function as well, we are going to write the declarator, and after declarator we need to put some brackets, and after within those brackets you are going to put all the code whatever this function needs to done. It was a very basic function which is going to print static line. So for this static line, what we have done, that we applied a loop from 0 to less than 45. So we exactly want to print 45 statics. So for 45 statics we also put C out. Obviously this end L is not going to be a good thing, so we can skip it, because if we are going to put end L, then it will. Okay, so we can write it in the next line, so it is not going to be in the loop part. In loop we have only static, so in loop we put static, so it is going to print the 45 statics, and after 45 statics it is going to be on the next line, and after that this function's working is complete and it will simply go back to wherever it was called. So this is your main definition of your function. The definition must agree with the declaration. It must use the same function name, have the same argument types in the same order, and have the same return type. Whatever you declared in your declarator in function declaration, that what is your return type, what is the function name, what are the parameters, and in which order. For example, if you have 2-3 parameters, then the order of the parameter also matters. So your declaration should be exactly same, or in other words your definition should be exactly same as the declarator, and have the same return type. Obviously the definition header is not terminated by a semicolon. The only difference is that whenever you are going to define a function, obviously you are not going to put the semicolon because it is continued. In the C++ language, what we already know, that if something is continued, then we do not use semicolon. If something is terminating or ending somewhere, so then we use the semicolons. Okay, so now come to the syntax. Little bit talk about more about the syntax of the function definition, which more or less we discussed. First of all, what you need is the return type. This is before the void main, you have to declare your function. In the function declaration, what you need to define: return type, function name, small brackets, and then your semicolon. So this is your declaration. Then you come to the main function, and within the main function you wrote your own code, and afterwards from here you can call the function. For calling the function, no return type. You don't need to mention the return type, but you also need to mention the semicolon. If there are some parameters, you can also add the parameters within the calling. When your main function will be ended, after the completion of your main function, you can define the definition of your function. In the definition of your function, you are going to have a return type, same as the declaration. You are going to have the function name, exactly the same as your function declaration and calling. Then you are going to have the small brackets, and within that you can have parameters exactly same as the declaration, but then there is no semicolon. but the important thing is these curly brackets. After these curly, within these curly brackets, you are going to write the main purpose, your main task of your function. So we have covered the quite enough information about the function, how we can declare a function, how we can define a function, how we can call a function, and what are the main advantages and the basics of the function, and within a function, how what are the components of it, for example its return type, function name, and the parameters, and so on. Before moving forward, there is a very important thing to compare the library function with the programmer or user defined functions. In library function, for example, you also know this get che function. Ch is equal to get che function. This function is a library based function. This function declaration and definition, we are not going to write it, we just call this function because this is a already defined function within our header files. What we all simply need is just to add this header file into our program, and then we can simply access this function. So declaration and definition of the library functions are not required. We can simply call them and use them, and they perform the functionality as in the background that is defined. The definition compiled into executable code is in a library file that is linked automatically to your program when you build it. Whenever you are going to build your program, you are going to run your program, then in the building process, what it will do that it will attach that file in which the definition and declaration of this file, function exist, and with your program that is also going to run. But if we talk about our own function, when we use library functions, we don't need to write the declaration or definition. But when we write our own functions, then declaration and definitions are part of our own source. For example, this star line function. Star line function do not exist in any library. If it do not exist in a library and but we need it for our program, then we must have to declare it, also define it, and then we can call it or use it. As I have said earlier that there is going to be one possibility in which you can eliminate the declaration or you can skip the declaration. For example, you want to skip the declaration, then the only possibility is that you have to define your function before it's calling. Like we can consider the same example, the same process here. There is a function 1, you declared it, you called it, and then in the later you have somewhere its definition. But if you want to skip this declaration, the only possibility is that you define this function before its calling, means before the main function. So first you need to define this function, then you can call it. If you are going to use this method, then you need to be very careful because there can be many functions. From function to function there are different callings, and there can be an ambiguity or the confusion while you are writing your code, that where we have to define it, where we can skip it, and if both functions are calling each other, then also a very big problem for that in that case as well. So for avoiding these type of problem, the best idea is to declare, call, and define later words. But there is a possibility, if you want, that you can define your function before it's calling, then you don't need the declaration. The second approach to inserting a function into a program is to eliminate the function declaration and place the function definition, the definition itself, in the listing before the first call to a function. So for example, see the star line example. This approach is simpler for short programs in that it removes the declaration but it is less flexible. To use this technique, when there are more than a few functions, the programmer must give considerable thoughts to arrange the functions so that each one appears before it's called by any other. Okay, now consider the arguments. For example, in the function, we want to send or provide it some information or the data from the caller function. Considering the same example, for example, we are going to print the star lines, but how many stars we want to print, we want to inform this to function, for example 45 stars, 30 stars, 2 stars, or how many number of stars, Or we can also more make it more interesting by adding the character. For example, we don't want to print the stars, we can want to print the equal sign, we want to print the something else, for example the hash sign, or some any other character which we want to print as a line. So we how we can tell a function that what we want to do. An argument is a piece of data, an int value, for example, passed from a program to the function, or you can say from the caller to the function body or the function definition. Arguments allow a function to operate with different values or even to do different things depending on the requirements of the program calling it. Let's suppose we decided that the starline function in the last example is too rigid. Instead of a function that always print 45 star x, we want to a function that will print any character any number of times. So for the example, we have to add the arguments in the starline function. Our problem is now a little bit enhanced, a little bit improved, that we don't want a function always print static. We want to tell a function what character you need to print, for example the dash, for example the equal, for example the dash, and we also want to tell the how many number of times you need to print. So it means to this function we now want to send two type of information. First, which character it needs to print. Second, how many number times it needs to print. So one is the character and one is the integer number value or the count for how much time we need to print it. Okay, first let's we see what changes we need in the declaration of the function. Let's suppose we are going to create a different function rather than taking or changing the same function, the star line. We are going to now create another function with the name of represent character, REPCHAR, char, represent char. So we are going to create a function with the represent char name. First thing is the return type. Like similar to starline function, this function is not going to return anything to the main function. It is going to print something on the screen, but it is not giving back any information or any data to the caller, to the main function. So return type is the same as the void. Function name, we changed it to the repchar, and after that we are going to add brackets, and within those brackets we need to add the arguments or the parameters. As we already have discussed, we have two type of arguments in it, two type of parameters. What we need to tell the function that which character it needs to print and how many times it needs to print. So first parameter is going to be char, the character, and the second parameter is going to be the integer number. You don't need to define the variable here, or if you want you can define your variable here as well, that character ch or int n. It's up to you that you want to add the variable names in the declaration or not. It is your choice. The items in the parentheses are the data types of the arguments that will be sent to repchar, as that is character and integer. Whenever you are going to now call this function, for whenever you need to call, what you have to do, you have to write the function name, then the parentheses, and between the parentheses there is going to be your actual data which you are going to send to this function. For example, I want to print a line of the dash of this symbol of, and the size of the or the number of times this dash need to be printed, it is 43 times. So our function name is repchar, and it is going to have the symbol minus, and it is going to be printed 43 times. So this is the two parameters which at the time of calling I'm going to send to this function. So this is our calling of this function. The value supplied in the call must be of the types specified in the declaration. The first argument, the dash character, must be the type char, and the second argument, the number 43, must be of the type integer. The types in the declaration and the definition must also agree. With respect to your declaration, first thing is you are saying this function is first it is going to get a character, and second thing it is going to get is a number. So the sequence of your parameter must be same in the calling as well as in the definition. Your calling, so first thing should be a char and the second thing should be a number or an integer. Similarly, this rule will follow in the definition. The next call to the rep char equal 23, we can call this function again with the different values. For example, I have sent this time the character as the equal sign and the number of time is 23 times. Tells it to print the line of 23 equal signs. The third call again prints the 43 dashes. These three calls are actually with respect to this diagram. That first we need to call this function and send dot with the 43, then we have to call this function again with the equal sign and 23, and then we have to call this function again at the third time, that is dots with the or the dash with the 43 number. The calling program supplies arguments such as dash and 43 to the function. The variable used within the function to hold the argument values are called parameters. In repchar, they are ch and n. These parameter names ch and n are used in the function as if they were normal variables. Placing them in the declarator is equivalent to defining them with the statement like char ch int n. When the function is called, its parameters are automatically initialized to the values passed by the calling program. Dash and 43, the arguments were constant. Instead of a constant, variables are passed as arguments. The user specifies the character and the number of the times it should be repeated. For example, you can ask from the user to enter the character it wants to print. So user entered plus. You also ask from the user to tell how many number of times you need to repeat it. User entered 20. So then you can pass these two variables to the function or in the function calling. The data type of the variable used for the argument must matches those specified in the function declaration and definition, just as they must be constants. This is ch in must be a char and n in must be integer. Sorry for this, actually it's like this: ch in must be a char and n in must be integer. When a function completes its execution, it can return a single value to the calling program. You have to remember it very strongly that every function can return a single value to the caller. It is not possible for a function to return more than one value to the caller. So every function, when a function is completes its execution, it can return a single value to the calling function program. This return the value consists of an answer to the problem the function has solved. The next example demonstrates a function that returns a weight in kilometers after being given a weight in the pounds. For example, we are going to cover another example in which a function is going to receive, as a parameter, is going to receive the weight in pounds, and then it is returning back the weights into kilometer, means it is going to receive some number, it is going to convert it into kilograms, and then it is returning back to the calling function or the caller function or the main function. When a function returns a value, the data type of this value must be specified. The function declaration does this by placing the data type float in this case before the function name in the declaration and the definition. Function in earlier program example returned no value, no return type was so void. The function lbs to kilograms to kg, pounds to kilograms, where lbs means pounds, return type float, so the declaration is float lbs to kg float. So how we are going to declare this function? Its return type is float because it is returning a float value. Its function name, that can be anything, for the we consider it as lbs to kg because, as I have discussed before, your function name should be with respect to its functionality. So its functionality is to converting from pounds to kg. And then we have to define that which type of data it is receiving. So it is receiving also a float. So it is going to receive lbs as a float value. It is converting it and then it is returning back as a float value which representing it in kgs. The function lbs to kg is passed an argument representing a weight in pounds, which it stores in the parameter pounds. It calculates the corresponding weight in the kilograms by multiplying this pound values by a constant. The result is stored in the variable kilograms. The value of this variable is then returned to the calling program using a return statement. How we can return it? We saw a simple function which can print something. Similarly, we can all add some calculation kind of a thing. But how we are going to return it? That we need to add a return statement at the end of the function so that our answer can be returned to the caller. Values passed by ch in and nin when the function call is executed will be passed to the function. When constants were passed to it, the function creates new variables to hold the values of these variable arguments. The function given these new variables the names, data types of the parameters specified in the declarator ch of type char and n of type int. It initializes. Okay, so now what's the difference? But whenever you are sending your data or passing parameters to a function, you have different types of different methods to pass your parameters. One is pass by value and the second is the pass by reference. Pass by value is work like that it creates a copy of the parameters you are sending. For example, the main function is sending some data, then your function will create a copy of that data and work on the copy of your data. Do not work on the original data. But if you want to make your function to work on the original data, then you will not send the copy of your data, but you will send the address of your data where the actual data exists. And your function is now going to work on that actual data in the memory, and whatever changes this function is going to create will be changed forever in the actual data existed in the main function or the caller function. Let's see how it works. Passing by value, it initializes these parameters to the values passed. They are then accessed like other variables by statements in the function body. Passing arguments in the way where the function creates copies of the arguments passed to it is called passing by value. Like for example, in the main function you have a variable chin and you have a variable n in, character in and the number in. You had some values in it, for example the equal sign and the 30 number. If you are going to send these values by value, you just have to, in the calling, you just have to represent or write the name of these variables. By writing only the names, what is the difference? That the copy of these values will be sent to the function. Whatever changes this function is going to do on these values, these changes will not reflect on the main function unless a value is returned and then saved into a different variable, then it's something else. But the parameters which you send to this function are not going to exactly the same as of the main function, because those are actually the copy of the original variables. A second method of sending the data to the function is passing by reference. A reference provides analyze, a different name for a variable. One of the most important use for reference is in passing argument to function. When arguments are passed by value, the called function creates a new variable of the same type as the arguments and copies the argument values into it. But when the function cannot access the original variables in the calling program, only the copy it created. Passing arguments by value is useful when the function does not need to modify the original variables in the calling program. In passing by reference, the function cannot access the original variable in the calling program, only the copy it is created. Passing arguments by value is useful when the function does not need to modify the original variable in the calling program. Passing arguments by reference uses different mechanism. Instead of value being passed to the function, a reference to the original function in the calling program is passed. It is actually the memory address of the variable that is passed. An important advantage of passing by reference is that the function can access the actual variable in the calling program. Among other benefits, this provides a mechanism for passing more than one value from the function back to the calling program. When a function completes its execution, it can return a single value to the calling program, as I have said earlier. This return value consists of an answer to the problem that function has solved. The next example demonstrates a function that returns a weight into kilograms after being given a weight in pounds. Return a value. Function, we already covered that function can be called without parameters. Then we also discussed function can be called with some parameter, with some values, and according to that the function can work. And afterwards, now our discussion is how a function can return a value. When a function completes its execution, it can return a single value to the calling function or the calling program. This return values consist of an answer to the problem the function has solved. The next example demonstrates a function that returns a weight in kilograms after being given a weight in pounds. When a function returns a value, the data type of this value must be specified. The function declaration does this by placing the data type, float in this case, before the function name. Function is earlier program example returned no value, so the return type was void. The function lbs to kg pounds, where lbs means pounds, return type float, so the declaration will be float lbs to kg and float. The function lbs to kg is passed an argument representing weights in pounds, which it stored in the parameter pounds. It calculates the corresponding weight in kilograms by multiplying this pounds values by constants. The result is stored in the variable kilograms. The value of this variable is then returned to the calling program using a return statement. So how it is going to work? In our main program, we are going to have a variable in which we have the data or the weight in the kilograms. Not exactly the kilograms, but in pounds. Whenever we call this function, we will send this data to this function. This function will create or convert that into kilograms, and then this kilogram will be returned to the main function, and then in the main function it will be stored and then further can be utilized. When arguments are passed by value, the called function creates a new variable of the same type as the argument and copies the argument's values into it. Means from the function we are returning a value which is stored in a variable, but it is going to be copied, or its values are going to be copied into a different variable into the main function. The function cannot access the original variable in the calling program, only the copy it created. Passing argument by value is useful when the function does not need to modify the original variables in the calling program. Similarly, for the reference arguments, a reference provides an alias, a different name for a variable. Passing arguments by reference using a different mechanism. Instead of a variable being passed to the function, a reference to the original variable in the calling program is passed, similar to your returning value. Now let's talk about overloaded functions. When a function is called, it's an overloaded function. An overloaded function appears to perform different activities depending on the kind of the data sent to it. Different number of arguments, for example the starline function and the representation char function, had more or less the same functionality. The starline function prints a line using 45 starx, while repchar function used a character and line length that were both specified when the function was called. Imagine a third function, charline, that always prints 45 characters but that allows calling program to specify the character to be printed. These three functions, starline, repchar and the charline, perform similar activities but have different names. That means 3 names to remember and 3 places to look them up if they are listed alphabetically in an application. It would be far more convenient to use the same name for all 3 functions, even though they each have different arguments. For example, if we are going to have 3 functions And if we are going to give all these three functions different names, rather giving them different name, we can also give them the same name, like for example the char line or something like that. If we are going to give more than one function the same line and all functions are having different types and different number of parameters, then this process is called function overloading. In functions, we also cover the recursive functions. Recursive functions are the functions which call itself. There are some possibility in your programs and in your logics where you need the recursion. We can consider the example of calculating the factorial. As we know, the 4 factorial is equal to 3 factorial, 3 factorial is equal to 2 factorial, and 2 factorial is equal to 1 factorial. So it means for finding the factorial of 4, we need to first calculate the factorial of 3, and for the factorial of 3, we need to calculate the factorial of 2, and for the factorial of 2, we need to calculate the factorial of 1. It means if we have a function which is going to calculate the factorial, then it will call itself for a lesser value. We gave it to 4, it will call itself for 3, that will call itself for 2, and then it will call itself for 1. This whole process of function calling itself is called recursion. The last main topic of or the main thing we need to cover in function are the inline functions. Function save memory space because all the calls to the function cause the same code to be executed. The function body need to be duplicated in memory. When the compiler sees a function call, it normally generates a jump to the function. At the end of the function, it jumps back to the instruction following the call. While this sequence of events may save memory space, it takes some extra time. To save execution time in short functions, you may choose to put the code in the function body directly in line with the code in the calling program. That is, each time there is a function call in the source file, the actual code from the function is inserted instead of a jump to the function. So whenever you are going to create a function as the inline function, if you declare a function as the inline function, it means whenever it is called, your control is not going to shift to the function, rather your function body is copied at the place of the call. Wherever you are calling it, your all the code of that function is now copied to that place so that your time is more accurate or you use the less time. How? You have a function that is an inline function and you are calling it from the three places, then rather the control is shifting back and forth. The function is how it is working, that this function is going to be copied at the place from where it was called. So it was all about our today's lecture. Hopefully you understood everything well. If there are some questions in your mind, please feel free to ask in our discussion session. Thank you. Allah Hafiz.